Hi, everyone, and welcome to Oracle CloudWorld. My name is Christian Shay. And today we're going to talk about developing and deploying database applications that use .NET in Kubernetes. So I'm going to take you through a brief overview of microservices in Kubernetes, talk about the Oracle Database Operator for Kubernetes. I'll show you the Oracle Data Provider for .NET Core. And then the last half of the session will be a demo showing you how to put it all together to do a shopping cart service for using .NET Core going to Kubernetes in the Oracle Cloud. So first we'll start with microservices and what that means, microservices architecture. So most of you probably already know what a microservice is, but I'll just read the definition here. Microservice architecture is an approach in which a single application is composed of many loosely coupled and independently deployable smaller services. So what does that mean? Well, it means that you're developing with well-defined APIs, meaning that everyone knows what they are, they don't change, or they just evolve. You are using private data sets, meaning that the outside cannot access the data directly. It has to go through the APIs. It encourages independent development and deployment, meaning that each microservice developer does their own thing, basically. Bounded contexts mean that each microservice has basically a very narrowly defined scope. It's not trying to do everything, just a small piece. So in this example, sales. And then loosely coupling across microservice means that you can upgrade one or work on one microservice and not worry about the others. They don't you don't necessarily have to upgrade all the microservices at the same time. They can be worked on independently. So some of the benefits of using microservices include the freedom to use different technology stacks. So individual groups working on individual microservices can use whatever they want, which leads to faster development and deployment and release because they're not dependent on each other. And then this also leads to the potential for maximum high availability and scalability. However, I would point out that it's also, if you don't do it right, it's also possible to end up with much worse performance and scalability than a monolithic application, because when things go wrong, they go very wrong because there's lots of microservices. And you have a freedom to choose different data models. One microservice can use a relational database, others can use whatever they want. And of course, this all ties in very well with the cloud native model. Some of the challenges, of course, these microservices tend to be chatty, so there's more communication and latency. The development involves integration across different microservices, so it's more complex. Another big one is tracing and correlation. So as a message moves through a series of microservices, as it achieves something, it gets difficult to correlate and trace all of the different microservices that it goes through. And then resiliency and recovery. If you can't automatically recover because of the complexity of the situation, you actually will end up much worse off than you were with a monolithic application because you'll have a lot of failure. And finally, data consistency and data management are always a concern. So how does Kubernetes fit into all of this? Well, another definition here, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So basically, Kubernetes allows you to manage and orchestrate containerized applications, and it promotes high availability and disaster recovery because you're constantly adding nodes, adding clusters, removing nodes. And that ties in directly with horizontal scalability. All you have to do is add some nodes to your cluster. And you can declare your goals, your configuration in YAML files. So Oracle offers the Oracle Container Engine for Kubernetes, also known as OKE. It's very easy to find when you're over on your Cloud Console. Just look under Developer Services and then Kubernetes Clusters. So when you're in there, you're going to want to create a cluster and then access it and manage it. So typically you will do your management through kubectl, which is a control mechanism for your Kubernetes cluster. You can either do it through the Cloud Shell, or you can do it, I prefer to do it locally on my machine. If you do it locally, you'll need to go to this part of the console where they'll provide a OCI command line interface command that will create what's called the kubectl, which tells kubectl how to authenticate with your cluster. Okay, next we're going to move to the Oracle Database Operator for Kubernetes. So what's a Kubernetes operator? Well, Kubernetes operators are software extensions to Kubernetes that extends the Kubernetes API to manage complex applications and their components. So Kubernetes is already designed to handle stateless applications, to spawn, kill, clean up any of these nodes in the cluster. But that's relatively easy with a stateless application. But what about stateful applications like a database that's complex? When something goes wrong, you can't just delete it. You need to have specialty knowledge of the database and the contents of the database to be able to know what to do. So for monolithic applications, you actually typically have a person involved who looks at the failure state and knows how to recover. That person might be called an operator. So, but Kubernetes needs to be automated. That's the whole point. So there's something called the Kubernetes operator, which automates the process of managing these stateful applications. So Oracle has what's called the Oracle Database Operator for Kubernetes, also nicknamed Aura Operator, and it does what it sounds like. It handles the automatic operator chores for the Oracle database. So, for example, it can handle the autonomous database in Oracle Cloud, as well as local containerized databases like single instance and sharded databases that run inside of each of the containers. So in the case of autonomous database, the operator can handle provisioning, binding, start, stop, terminating, scaling, upgrading, observability. So this is the Oracle Database Operator, which I'm going to be using in my demo to bind to the autonomous database I'm using. It has a home in GitHub, and you can see the link in the bottom left-hand corner. So in order to install the Oracle Database Operator, you just go to that GitHub page. It's very easy. They have great documentation there. And what you do is first you need to install the certification manager, the cert manager, and that's easy. You just use kubectl apply with the cert manager YAML file. And then you need to generate a config map and a secret, or set up instance principal, as it's called, to give access to the operator to get into the Oracle Cloud. And then the install is very easy. kubectl apply Oracle Database Operator.yaml. So how do you provision an autonomous database using the Oracle Database Operator? Well, they have samples. You can take a look at autonomous database _create.yaml. Basically, you just take that file and you go in and get your compartment ID. You create a Kubernetes secret that contains the password. And then you prepare the YAML file with the OCID and the secret name. Now, in this particular slide, I feel I'm obligated to tell you that this is just for the demo, that we're doing it on the command line. It's not recommended to pass passwords on the command line. You would probably use a vault or something to pass the password. And then after you put those two entries into the YAML file, you apply it, wait a few seconds, and then look in the console or use a command line to see if the database is available. And then in the case of an existing database, you would use autonomous database _bind. And so that's an existing autonomous database. You just want to bind to it. Again, you get the OCID, you modify the YAML file with that, and then you apply the YAML file, and that's it. And you can check to make sure that the resources available. You can say kubectl get ADB. And in order to use these, you do need to have a wallet secret, because autonomous databases, well, one of the ways to access them anyway is a wallet. So you would create the secret here. Again, this is command line, but it's only for the demo. And then you would modify autonomous database _ wallet to create the secret. Okay, moving right along, the next, before we get to the demo, which is going to be using .NET Core, let's talk about .NET Core. So .NET Core is a lightweight cross-platform, meaning Linux, Mac OS, and Windows, rewrite of the .NET framework. And Entity Framework Core is Microsoft's ORM. So the Oracle data provider for .NET Core, produced by Oracle, it implements standard ADO.NET data access model. And it's extended with all of the native Oracle database features that you're used to. So things like rack, performance, scalability, security, data types, XML, etc. It's also written completely written in managed code. So it's similar to if you're familiar with thin JDBC. So that means it's small and it just uses a DLL. You would get this from NuGet, which is Microsoft's package manager, and use Oracle Managed Data Access Core is one of them, and Oracle Entity Framework Core is the other. I'm going to be showing you this in the demo in a minute here. So speaking of the demo, what I'm going to be doing in the demo is I'm going to be using a Visual Studio, but you could also use Visual Studio Code. And I'm going to use what's called ASP.NET Core Web API project template. So this is a project template Microsoft has that's particularly well designed for web services. So I'll implement get, post, put, and delete using that project template. And then I'll use the Oracle data provider for .NET Core and Entity Framework Core for data access. The application will need the database username and password. So Kubernetes will handle that. So basically, we're going to have a secret that has the database password and username, and that is going to be automatically put into the environment of each container by Kubernetes. And similarly, the app is going to get the wallet from the file system, which is handled by Kubernetes as well. It's put into each container that's spawned. It's put into the file system. So when we're done, we're going to test the service locally using a browser or Postman, and then use Docker or Podman to build and push the container out to a container registry, such as the Oracle Container Registry. And then once that's all done, we will run. The deploy YAML file to deploy this into Kubernetes, and then do the testing on the actual cluster to see if the service is running properly. And we're going to do all of that right now in a demo. Okay, I have Visual Studio here, and for our shopping cart service, we're going to use a web API project. So let me show you how to do that. So new project, and you can search on web API. You can see it right here. So I'm going to choose that type, and I'm just going to spawn the default project here so you can see what it looks like. So by default, they create a little weather forecast service, and there's a startup file, but the most important one is the controller. So if you take a look at the code for the controller, you can see that it handles the get method on the service, and you would modify it from here to create your service. So this is using .NET Core. And so now I already have a shopping cart service created. So let's go ahead and open that here. And so you can take a look, and you can see that I have a full-fledged project here. So let's start by taking a look at some of the things I'm using as I build this. So first thing is dependencies. So if you take a look at some of the packages I have inside my project, the big ones are I am using Oracle Entity Framework Core and Microsoft Entity Framework Core tools. So what's that? Well, Oracle Entity Framework Core also brings in the Oracle Managed Data Access Provider. So this is a combination of a ORM and our data provider. So the Entity Framework is Microsoft's ORM, and Oracle Managed Data Access Core and Oracle Entity Framework Core are the components that handle the working with the ORM. Okay, so that's how you get the data from the database. Now, we need to modify the applications to service the requests, but also we need to connect to the database to get the data. I'm going to be using Oracle Autonomous Database, as you saw in some of the slides earlier. So now, as part of using Entity Framework, you'll notice that I am using models over here. So I have a cart defined. I have cart items. So each cart has cart items in them, and cart context. So that's how an entity framework works. There's no database code in here. It just knows how to take these entities and put them in the database and pull them out of the database. Okay, so the real meat here is going to be partially in the startup file. So let's take a look at the startup file here. This is just where I do my connection to the database. So you can take a look here and see that right now I am configured to do a local connection. In other words, my wallet for my always free autonomous database is here locally on the machine and see Shay users Oracle network. However, when I go ahead and build this for the final time, I'm going to switch it so that it uses the container locations where we're going to deploy this into a container in Kubernetes. So keep that in mind. And then it pulls in the Kubernetes secret to get the username and password to the database there. Okay. And then, so that's how the database connection is set up. So now let's take a look at the controller. So the cart controller is over here. Let me open that up, and you can see that I handle get the cart, I handle post to the cart, put items in the cart, and delete items in the cart. And you can see that this is all dealing with entities. There's no direct database access here. I'm using Entity Framework. So I'm just dealing with carts and cart items. And then Entity Framework does the magic of doing the inserts into the database. All right, so now that we have this, let's go ahead and test it out. Okay, so as you saw in the startup, you saw that I create a connection to the autonomous database. And so the first thing we'll do is we'll just look at my shopping cart. So I'll go ahead and I could build it, but I've already built it. So I'll say start without debugging. And the nice thing that Visual Studio does is it has a little built-in IIS web server, and that web server automatically launches pointing at my service. So I can just quickly look and see that, yes, it's bringing in my carts. There's the Shay cart with some cart items in it. That's kind of hard to read. So the other thing we could do is we could actually call this in something like Postman, which makes it much easier to visualize some of the items in my cart. And I didn't use Swagger in this demo, but if you use Swagger, then the browser results are much more elegant, as you probably are aware of. Okay, so now we've run the app locally. Now we need to modify the autonomous database connection so that I can actually push this into a container and run it. So let me go back into the app here, into the cart controller, into this startup. And I'm going to change this to comment out. Make sure I'm not running. Okay, I'm not running. Comment these out. And uncomment the lines that handle the connection. And I'm not sure if I zoomed last time, so I'm going to do it so you can see it a little better, depending on your resolution of your screen. Okay, so what you can see here is that this is the wallet file to connect to the autonomous database. And by definition, because of the YAML files that we're going to be using to deploy into Kubernetes, those credentials are going to be put into a mounted volume in a directory called dbdemo.creds running in the Linux container up in Kubernetes. And then these environment variables will be passed by Kubernetes as a secret into the environment of the running container. Okay, so that's how it's going to get the credentials. But I need to rebuild this. Okay, let me pin this again. And just make sure that my output is okay. Yes, it succeeded. Okay, so next thing I want to do is to basically take these files that were built and tar them up so that I can put them in a Docker file and put them into a container. Okay, so a nice way to do that, there's other ways, but a nice way to do that is to say build, publish. Let's try that here. Build, publish. Hopefully I cleared out the directory here. Let's just make sure it's clear. Yes, it's empty. Okay, and let's go ahead and publish it. So this is basically putting the release files into a directory so that I can tar them up. Okay, that's where it's going to go. Now let's go back there, and there you can see it created all these files. Okay, so I'm going to take all these files, hopefully, and then I'm going to create a tar file. Add to archive. Publish.tar. You can see that. Okay, and there it is. So the last thing I'm going to do is just copy this file over to my Podman directory. And let me just show you how this gets published. So I have a Docker file here in my Podman directory. I use Podman. You can use Docker if you want. But this is the Docker file, okay? So I'm using Microsoft's ASP.NET container. And then I'm just pulling in the publish.tar files that we just built. I'm exposing some ports, changing the work directory, and the last point is the entry point of the application. Okay, so that's it. Right, so that's what I will execute from Podman. Now, because of time constraints, I'm not going to push this all the way up into the build. So let me show you some of the commands that I would have executed if we had time for this demo to show that part. So here they are, commands. Let me zoom in on them. So Podman build, and then I provide my Oracle Container Registry address, location, and then tag it appropriately, and then push the container up into the container registry. But as I mentioned, we don't have time in this demo to show that because it takes a little while to push it up into the container registry. So just remember that the name of it is this tag here, okay? Because you're going to see that again. All right. So that being said, now I tend to do my Kubernetes operations from another computer, and it doesn't matter now because the container file is up in the container registry, so I don't need to use this machine anymore if I don't want to. So I'm switching over to my other machine. All right, and so I have Kubernetes kubectl installed here. So let's check just to verify there's no pods installed on this machine, and if there are, I will delete them. But right now, let's take a look at Kubernetes kubectl git pods, no resources found. So I don't have any pods in there. And then now we're going to look at cart deploy.yaml because we're going to actually deploy this now. So if you take a look, This is the YAML file that we're going to deploy into Kubernetes. And you can see that, yes, it's using the image that we pushed from my other machine up into the container registry. It's providing a couple environment variables, cart user, cart password, and the credentials. So you can see that the cart password is coming out of a Kubernetes secret, as well as the credential files. So at no time is that information exposed. It's being done all through Kubernetes, and the container will just have those in the environment, and we'll just see this DB demo creds directory right there in the container. So that's how it happens. All right, so let's go back, and now let's go ahead and apply that YAML file. So let me see if I can find it here. There it is, kubectl apply. Excuse me. All right, let's run it. And so this is now pushing the shopping cart service into Kubernetes. And it says that it's created, but sometimes, you know, they error out. They give an error and they're not running. So let's take a look. Let's do a git pods again, just to prove to ourselves that, yes, it's running. And there it is. It says running. It doesn't say error, so we're in good shape. Okay, so the last thing we need to do is to use some port forwarding to test this. So all port forwarding does is it sets up a local host port that you can use to test web service calls against Kubernetes. So let's try that out. So actually, I think I have this stored here, so I don't have to type the whole thing. Let's see if I can find it. There it is. So kubectl port forward shopping cart prod 5000:5000. So that means it's going to be exposed on port 5000. And there you are. It says it's forwarding. And as you connect to this web service, you'll see messages come through here saying that you've done so. So let's come over here to Podman. So I've got Podman up here on this other machine as well. And you can see right now it didn't get a result the last time I ran it. But let's go ahead and execute on port 5000. And there you have it. So Podman is showing me some more of these items. And we've shown to ourselves that Kubernetes is working. And now we can go ahead and do a full-fledged deployment of the cluster if we wish, which includes some other steps. But the main thing is that right now you've done a successful deployment. Okay, and then last couple of things I'd like to mention are just some troubleshooting steps, because Kubernetes can kind of drive you a little nuts sometimes when there's errors. So a couple of things I found that were very valuable. Hopefully you'll be able to note this down. But the first one is how to look at logs. Okay. So the first one is a kubectl logs. Okay. So if you do this, it will basically show you a tail of the logs that are going through. And so if there's an error, such as a connection error, you'll see it here. And that can be very helpful if you've missed a step and just can't remember what it is. Now, in this case, any of the errors that you see are going to be benign. These are not real errors. They're just warnings, basically. So that's the first thing I wanted to show. The other one, which is really useful, let me CLS here to make it a little easier to read. Okay, the other one that's really useful is to actually go into the container itself by using kubectl exec, and then kick off a bash shell. And this is great because you can actually go into the running container and look at what's happening in case it didn't extract properly, the environment variables aren't getting placed. So first we'll say ls to list it, and you can see that there are all of the shopping cart files that we pushed up there and extracted in the process of creating the container. Okay, the next thing you can do is you can go to the location of the credentials. So cd/dbdemo/creds. If you recall, that's where Kubernetes is putting the secret of the wallet. Okay, so let's list that. And you can see there's my wallet file. Okay, and the final thing is let's look at the environment variable. This will show you my password, but I really don't care. Okay, so if you go up in here, but that's why if anyone has access to your container, they know your secrets. So if you take a look at the environment for this container, well, there it is, my cart pass and my cart user. All right, well, that was a lot of demo in a short period of time, but it shows you how you can create a .NET core application service in Kubernetes, and hopefully you can give it a try yourself. So we have some websites that might help you. otn.oracle.com/.net is our .NET primary site, and we have samples over on GitHub. If you're interested in getting updates on some of our .NET products and when they're getting released, you could follow us on Twitter, and we do have a YouTube channel as well that has videos like this one under the Oracle.NET team. With that, I'd like to thank you for joining my session, and I do hope you have great luck trying this out yourself. Bye, everybody.